Swayam Prabha. Digital India. Educated India.
So let's start now. We want to concentrate more on the polymorphism side. Just to recap on the varieties of abstraction, somebody asked me a question about this classes and all this thing abstraction over data, and then there is a abstraction over computations through the procedure we are familiar with. Now what we are talking about is a more of a abstraction over type. Okay, that's a polymorphism, because we are defining a type variables as such, and or we are constructing, composing or on top of this particular type variables. Like for example, point as another class you might have used it many times or defined. Point is a class which can take a integer as a one of the parameter, or it can be double. So it is a point can be defined for using the discrete values or using the real values. Okay. So abstraction over types is what we are talking about in this polymorphism, and the polymorphism, kinds of polymorphism, I have been talking about that earlier. This is a very good diagram actually, which appeared in almost it's in 76 actually or something like that. There is one very good paper by Cardelli and Wegener. Okay, and this guys, that paper is understanding types, data abstraction and polymorphism. Okay. And that particular paper actually, this diagram talked about this universal polymorphism, which includes the parametric and the inclusion, ad hoc, overloading and coercion. Obviously we talked about the parametric to some extent when we said that okay, the function algorithm can be defined for generic type, okay, over generic type rather to say, and it can be applied for integers or float or maybe a string as such. But we will talk about more about this parametric polymorphism. We talked about the overloading and the coercion. We will briefly touch upon that again, but let's start with the parametric. And there is one more thing that it talks about universal polymorphism is about, also includes this inclusion, which is a subtyping. It's a kind of inheritance, but inheritance also has a hierarchy. Here we are talking about the subtyping only. So we will talk about that, and then there is with this object oriented languages, interface has become a very common in fact a mechanism which actually formalized this polymorphism. How? We will talk about that. Okay. So polymorphism having many forms, as we have already mentioned, and that allows types to be parameters to functions and other types. Type of a function depend on the type of parameter. Define an algorithm once and you have the basically for the specific data, and definitely it will be applicable for that. So let's go move forward with this particular definition, and then we have already seen this polymorphism where the polymorphic function we have talked about. Now let's talk about the polymorphic classes. So you guys are using it in Java or even in C++. List of, let's say, integer you define, you instantiate that particular generics basically, or the polymorphic type. Okay, you instantiate that with whenever you say that the array list of integer, array list of strings, then you are instantiating that array list t, which is t is a parameter that is there, correct. And this is one of the example here shown that you are defining the, here I have chosen the interface list e, but it can be a class. E is a parameter, type parameter. Okay, we are talking about a type of list E. Okay, and you instantiate it by saying the list of float or list of strings, or it list of, let's say, T as such, any user defined type. Sorry. So typical Java parametric Java usage of parametric polymorphism, as I mentioned just now, that array list is one of the predefined library class as such, and there is a, you can say array list A type can be string or whatever it is, you can define that, and you can define that particular type as such. Okay, sorry, variable of that type, correct. So here we are saying the names is a variable of list string and you are defining that particular array list string here, you are instantiated that array list. So this generic library usage is a one part of it, definitely we do that many times. Now we should be able to define our own also, we should be able to add our own also. So for example here it is we are saying that okay, I want to define the set as a generic type, and that set generic type I will the element of set, maybe it is a set of integers, obviously set is different from list, right, correct, no, because there cannot be a duplicate, set is a correct, right. So so I want to define the set as a generic type, and my set t can be integer or string or whatever it is. So I will define that particular as a generic type, where I will use internally maybe list internally as a this one, and I may represent certain other operations on that particular t as an element, where I will be able to search that okay, whether t, that particular return t if it whatever the first element that exists. Okay. So there is a, let us take another example in C++ where the minimum min is a function that we have defined, and that takes C star, the pointer to that particular C is a parameter, type parameter, and that we are defining that particular minimum function here. But the thing is that here if you can see that I am relying, okay, I am relying on the predefined operations less or and equal to assignment and less here, okay, which C should be defining. C should be defining that. If C does not define that particular function, then this will not work. So there is a constraint that is there. So I will not be instantiate this min for something which does not have less defined, less than defined or assignment defined. Am I getting it? Is it clear? So how to represent this constraint to make procedure more generic, okay, more usable, and or maybe a not generic I will say, it is more of a consistent as such, okay, how I can do that. So let us take an example here that in case of ADA kind of language, you can in fact pass that less as a parameter, by the way, you can pass less as a parameter, the type sorry operator as a parameter. That operator I can pass it as a parameter, when I instantiate I can pass operator as a parameter, whereas in case of Java kind of languages I can define that constraint, this is called as a bounded types or something like that, okay, I can define that particular binding constraint by saying that t extends comparability. So there is a comparable t, then only I can use it, that means I can use that compare function, I can use this compare function here, and that is a basically restriction comparable. Now this sort actually can be instantiated easily for those types where the comparable is implemented by them. I will not be able to use it for any other type which does not have this comparable implemented. So that is the way I am restricting it, and this is constraining it, and that is the way basically I can instantiate it in a much more consistent way. Without fail it will work, because that constraints are satisfied. Okay. So so for one of the example I will you can check that later, you can see that many of these examples exist actually, even in the web you will find, and you will find in many books that, for example, there is an insertion sort here where we are saying that t extends comparable t, that is a t is a type parameter, where the comparable t, obviously t is implementing that comparable, and that is as it is implementing that comparable, obviously there is a you can use that particular compare to as the operation here, and that is why you can basically do the sorting, otherwise you will not be able to do the sorting. Okay. So comparable is a one of the predefined type, predefined class from Java library. Okay. So our last example, if you remember that first example, earlier example, basically we started with is sorted. Is sorted also I can restrict it to say that v extends comparable, then I can do that. V extends comparable, then only I can use this particular is sorted. I want to allow is sorted to be used only for t and v array of v, where V is actually extending that comparable. So that constraints actually I am defining now on top of it. Okay. So this is a exercise you have to do it. I will send across the PDF actually so that you can check that. But what you have to do actually, you have to modify it further. This particular example, that is exercise. I will share that in fact later. That's okay. In case of ADA or C++ as such, it's not only the T, the type can be the parameter for generics. You can also pass actually the this particular value as a parameter. Okay, apart from T, you are passing the value as a parameter also. For example, here in the C++, you are passing this max atoms equal to 200. You are passing definitely a atom. You are passing this atom as a type parameter, but you are also saying that the maximum atom, this Q, I am defining the Q as a one of the class here. This Q is a generic class, and this class is applicable for this Q is of class atom. Okay, Q is of atom, basically Q is of atom, but the restriction that I am saying that maximum size of the Q, maximum size of the Q will be only 200. So that is why I am saying here default parameter is 200, but when I instantiate I can say that okay, this particular Q is actually, sorry, I will just, this Q, can you see this? Okay, this Q, when I instantiated this, it is a only can be a, will be a size of 50 only. So obviously we are using this value parameterization along with the type being passed as a parameter. Okay, is it clear? So value parameterization along with the type parameterization is what this languages started providing as a part of this particular generics and generic instantiation. Okay, so this actually helped to implement certain in a better way in certain particular maybe a classes and certain particular abstractions. Okay. In case of the ADA also provides this particular value parameterization. This is a complex to explain at this stage if you are not familiar with ADA, but it is not that this one complex. Generic is a word that is used by Java, sorry, ADA. You define the packages, that is the modules in case normal sense, modules which are generic, or procedures which are generic in ADA, and the generic actually is a prefix that you specify before this. The first part of that particular thing is called as a specification, okay, like a .h file in case of C++, okay, it is a specification, okay, and then this is the implementation of that particular thing. So here the stack as a one of the abstract data type that we are defining here, that stack is actually represented by this particular operations and this particular exception, and then this, when you instantiate this stack, you instantiate it with the stack of particular atom, that is a particular type, maybe integer or whatever it is, other things, and but you need to define also the size as a value parameter to say that okay, this is of this particular stack, maximum size I am expecting is, let us say 50 or 100 or whatever it is. Okay, so this is a basically a generic parameterization we have seen, and this and also there types as a parameter and also value as a parameter. Are you getting it? This is a basically so you can define certain things, you can in fact do not look at the polymorphism whenever we say that okay, there is a, we talked about this function as a polymorphic, classes polymorphic. The classes polymorphic, you need to, you can apply certain constraint to those types that are you are passing it as a parameter. You in some languages you can also pass value as a parameter along with type parameter, along with type obviously. Okay, that makes better sense. Otherwise it will be monomorphic with that particular size constraint. Yes, I mean it may be useful sometime, but not really. Okay, now coming to the next part of polymorphism, we have talked about this parametric polymorphism, we talked about the ad hoc polymorphism where we said the overloading, and also what is that, what else, coercion, good. So you are attentive. What else we talked about in polymorphism? Inclusive. We have still not talked about that inclusion subtyping as such. We have not talked. But before that, in the parametric polymorphism as such, I mean, I consider this as more as a parametric polymorphism. It's a interface actually. What is interface? Interface should we consider as a type, because we cannot actually instantiate that particular. Okay, you cannot define a variable of this type, right? You cannot define interface. So interface itself is a type variable actually. Consider interface as a type variable. Okay, that is the simplest way of, I always mention this. Interface actually formalizes the polymorphism in a different way, because you are defining certain operations, behavior, okay, and you are implementing those. There may be a multiple different implementation, multiple forms you can have, multiple implementations you can have, and it is also kind of polymorphism that you have. Interface as such is a basically, so it is the, what is a type ultimately? It is a set of elements, right, of certain, having certain, exhibiting certain, loud, okay, certain behavior, right, exhibiting certain behavior, right. So there is a set of elements, okay, from and exhibiting certain behavior. Obviously its behavior is defined here. Set of elements will be the one which actually will be, in fact, when we have this is basically a stack kind of elements, okay, and we are basically, when we implement it, there will be different kind of implementations that exist, combination of that. So type variable is always a combination of the different types associated with that type variable, correct. Type variable is actually, whenever we are saying type variable and the polymorphism, type variable is nothing but a combination of maybe a integer values plus this values plus that values, xyz values, right, correct, because that is a way, and when you instantiate it, we are restricting it to the integer of stack or this particular stack, correct. So here interface, actually interface is also a kind of type variable, okay, and the parameterization that comes through, so parameterization can be further in case of interface, because interface itself can have actually can take a type parameter. So whenever you instantiate, but the thing is that there is a way to implement this particular kind of interface, and you use in Java, generally we say implements interface, and you can say that the stack of integer implements I stack interface T, okay, which is basically this particular kind of interface. If we implement this particular stack, then it becomes just a stack of character, only the implementations will change, but the thing is that it will still remain the, this will still remain the stack of character, correct. Just the implementations may change, because one place I may use a linked list as an implementation, other place I may use array as an implementation, or whatever it is, only the implementation. So many forms will be actually only from the perspective of implementation, interface remains the same, correct. So behavior will remain the same, correct, but here basically it is more of a, now we are defining that particular interface of T, that means I have more polymorphism is really existing in a real parametric way, okay, correct. So this is an example that you might have seen many times. Shape is one other class that you might have, okay, this is a standard one. Now it is a basically shape interface, again as we said that there are different operations obviously, and these operations may be implemented by tube some way and pyramid some way and a cube some way. So it's a realized by various classes, it's a polymorphism again. Okay, so in general actually this particular object oriented languages do not talk about interface too much about the interface, and but the object oriented technology, they use extensively this interface concept, and they talk about this interface as a contract basically, that you can implement it, and you define this more of a interface, you define the interface so that the system can be in fact used in a uniform way. Okay, we have seen that earlier, that all this modularization and all, but modularization is good, but beyond that when the system it is used to be used, it defines that certain interface through which you use it, correct. So interface is a formalizes this polymorphism in a abstract way. Again the interface is also is related to this polymorphism. So everything is evolving around this polymorphism, right. We have seen from the how basically this things are even the overloading, we talked about the coercion, we talked about the parametric and we also talked about now this particular interface and all. So two elements are polymorphic with respect to the same set of behaviors if they realize the same interface. That is the way it is a polymorphic, that is the way that it is looked at, and then you can in fact implement plug and play architecture, and that is why interface is considered very important for implementing the polymorphism in real life systems. Okay. Now so in any case you can see that okay, if I have implemented let us say stack using array or stack using linked list, but if I am actually the interface is the same, obviously I can replace one by another. So there are different ways of forms actually that exist. Okay. So consider this example as something different actually for you guys. Microwave as an interface, and microwave is implementing, and the client 1 is using it, client 2 is using. Initially there are two operations that are there, cook and stop, cook and stop, correct. Now few days later client C1 wants to notify to the workaholic client, he wants basically a notification to be sent that okay, you have started it, you have not stopped it, okay. So but the thing is that client C2 wants chime whenever the cooking is cycle is on, okay. Two different requirements, remember that, correct. There is a one way that okay, actually I can provide change the interface, that is a bad idea. Change the interface and I add both this chime and notify, and I say that okay, microwave implementation, new microwave implementation implements this both, okay. Client C1 does not want chime, client C2 does not want that particular buzzer notification, but still he gets it, okay. In fact they lost a chance of introducing another product, okay. So what will the wise basically OEM vendor product company will do? They will introduce new product, okay, one which provides a notification, another one which chimes, and they now if you look at now here from our perspective, object oriented languages perspective, microwave interface has not changed. That is a very important interface, the contract remains the same. There is another interface that is implemented now, which is the notify by microwave 1 implementation 1, and implementation 2 has introduced a chime, so correct. So interface actually has to be used wisely, and that definitely you can it formalizes certain type of or way of doing the polymorphism multiple implementation, but they are used wisely, okay. So coming back, we talked about this particular part, now we are going to get into the briefly again once more about this ad hoc and all, and then I will go to the inclusion. Inclusion is very important, I will go to that soon. The reason I am talking about this ad hoc polymorphism here again is that I just want to show some of the example, like C++, this operator can be defined here, that you can define this operator plus, you can see that here, this is the operator, complex operator plus is defined, okay, and this is a part of this particular complex class that is defined here, and this particular plus operator actually now allows you to use, right. So this is one of the same thing, even in a different way, it is not an operator overloading, but overloading is a important part of even Java. Java allows you to overload procedures and functions. Some has been in fact overloaded here, some is overloaded, signature is different here. Here the obviously the signature is different, but there is a very interesting part, Java has a problems in fact, that if I say here, if I do not cast this by float, I do not know how many of you have, if you do not cast this by float, it is a error in Java. actually it is not able to in fact infer that I should use this sum even though I have given here 20.0, because there is a coercion part comes into picture, and there is a actually it is a there is a challenge actually in fact, and it tries to apply this long, and it says that I cannot actually, this is a static error by the way. Okay, if you remove this float, it is a static error, so you need to cast it with the float. Okay, so this particular overloading also is allowed in Java, but in a different way. Obviously operator overloading is not there. Normal overloading is also there in C++, but operator overloading is also there. ADA kind of languages also allow this particular kind of overloading, and I will not get into the more details, but just want to highlight here one part that you can do. This is a kind of overloading here, min here we are defined, but you can use a generic, that is a part in a very systematic way to avoid too much of overloading functions to be defined by USL. So what you can do is that this particular min takes this parameters here, so I can pass this particular parameter as a t, and then I can also pass this comparison operation, and then in that case is actually I can define integer main and all this thing as a you can instantiate this particular minimum in a different ways as you want. So what is happening is that you are actually avoiding this too many of operator overload, too many overloadings actually. So overloading actually is considered, that is why it is considered ad hoc polymorphism, because it is actually speaking it is a you can sometimes you can get away with it, and it is the ad hoc way you are actually trying to provide a multiple operations on the multiple types actually. Okay. So this is a way that you can do it in a much better, this way you can do it in a much better way, correct. This is the, we are using here parametric polymorphism, remember that, and we are passing this particular as a parameter, correct. So this is a better way of doing it, right, rather than doing this way. That is the reason I have given this example here. Okay, so certain languages you require certain generics. We talked about the instantiation of generics, right? We talked about the instantiation of generics. In certain languages you have to do explicitly, in certain cases, certain places you do not have to do explicitly. For example, Java allows Java actually you do not have to instantiate function polymorphic functions. Okay, you do not have to instantiate explicitly polymorphic functions. So for example, I have, hopefully I have the example, yes, this one. So for example, this sort function, if you have defined it, then I can just array entire and then call it. You cannot just call it and it will automatically instantiate. That is like C++ or Java. So initialization, so this particular instantiation of this function polymorphism is it differs in different languages, and that is basically something that. Okay, now coming to subtyping. Okay, let us talk about the subtyping. Very interesting, and you know all subtyping. Actually you might have used inheritance and all, but we are not talking about a complete inheritance and this one, we are talking about a subtyping. Okay, subtyping is here. Let us take an example. It's good to learn from the example. Savings is a subtype of account. Okay, savings is a subtype of account. That element of class savings can be considered also an element of supertype account, right? Is that correct? Element of class savings can be considered also an element of supertype account. Is that right? Why? Yes. Huh? Louder. Is a type of account, is a relationship that exists, is a type of account. Okay, but this is a is also need to be okay, well established, need to be defined further. Actually yes, I mean definitely there is a this particular, in this case it is a subtype relationship says that this particular savings element of class savings can be considered as also an element of supertype account. That's there, but how basically then what will happen if I define an array of account and array of savings? Can I say if I define array of account and array of savings, can I actually now say that array of savings, okay, elements of array of saving or elements array of saving itself, okay, is also element of array of account? Is it? Got it? Okay. So that's a very interesting actually. Whenever we talk about the subtyping, okay, subtype relationship is very important, and there are certain restrictions actually in certain languages, okay, and we will talk about that as we move ahead. So think about this problem, and we will come to that particular solution of that or answer to that in 2 minutes. Okay. A is a subtype of B if every object of type A is also B. That is what we are also saying here, and then all of so every object of type A, all of the data members has all of the data members of B. Okay. So what we said, A is a subtype of B, that means savings is a subtype of account if every object of type A, every object of savings is also a account, correct, and every object of type account savings has also all of the data members of account, all of the data members of account, that is correct. You want to recheck that example, you know that. Supports all the operations supported by B, that is the account, with the operations taking the same argument types and returning the same type. Now remember here, same argument types and returning the same type. Okay. Here is a sometimes a catch whenever we talk about the polymorphism, we will talk about that further. And these operations and fields have the same meaning in A and B. Okay. Push pop is there. Okay. Now let us take a account as such, withdraw as a account as accounts withdraw operation is also in savings. Okay. There is a withdraw there, and there is a withdraw there, the signature, okay, that signature is the same arguments it should take, okay, and returning the same type. Okay, then it is a basically that particular operation is obviously I am taking that as a inheriting that particular thing. Okay. So what actually is a subtype principle as such, and that is a very important for us to really understand here. For any operation that expects, I am just trying to relate this now, for any operation T, operation that expects an object of type T, it is acceptable to supply object of type T dash where T dash is the subtype of T. Now this is where we are saying that if withdraw, actually now instead of taking account as a type, account as a parameter, it will take savings as a parameter, because savings is a subtype of account. So this is a subtype is a, now what has happened, where is the polymorphism here now, because there are multiple withdraws here first of all, right, and the right withdraw is applicable at the right place. Okay. But remember that right is applicable, that means are both the withdraws applicable? Are both the withdraws applicable? If the withdraw is defined in account and withdraw is defining savings, are both withdraws applicable still? Okay. Let us consider it this way, that whenever I am passing a certain parameter, okay, let us take an example that let me go back. Let us take an example that the create statement is not implemented by savings, So obviously create statement takes a parameter as savings also and account also. So it is applicable. So there is a constraint. So there is a definitely there is a constraint that it has to be the super type has to be, it has to extend account, So that for all of them create statement is actually applicable or correct. But so that is why it is a, obviously there is a polymorphism concept coming into picture. So subtype, so again here if you look at this definition itself, any operation that expects object type T, it is acceptable to supply object of type T dash where T dash is a subtype of T. That means there is a polymorphism here, correct. You can have multiple types as a input, right. So coming to the let us take a slightly some interesting things now here. so that you can at least relax from the some hard this one. So, let us take a simple example that this thing you might have seen many times, that animal is a class and the lion is a subclass, correct. Now, whenever we say communicate, what happens if we do not have a polymorphism, we will be saying that if animal is equal to lion, then lion communicate, animal is equal to tiger, then tiger communicate. But obviously with polymorphism, here subtype polymorphism we are talking about, it is a communicate is actually a one particular thing, and it will be obviously the particular communicate will be called according to the type that is a parameter. Okay. So, there is a communicate actually can be used for animal, can be used for lion, can be used for tiger, correct. Now, there is a very interesting thing here. I talked about this array, correct. I talked about this array of account and array of savings. What can I actually wherever, so what is the relationship? Subtype, definitely savings is a subtype of account. What about the can I whatever the operations I am talking about on savings and account, I am saying that they are applicable even on the savings actually. What happens in the case of array of savings and array of account? So, there is a very interesting, and not every language supports this, by the way. There is a, and there will be restrictions that will exist, and we will talk about that restriction in Java that I know of. So, remember that it is a whenever we say that okay, there is a like a array is a one of the term basically. If a term has a type A and that A is a subtype of P, then the term also has a type B. Okay. That means array of savings also is array of accounts, that is a way it is saying here, but this is applicable in certain cases, not applicable always. Let me just repeat it. So, whenever I have a operation which operates on array of accounts, okay, array of accounts or array of savings, let us take as array of saving, then I can also have I can apply the same function for array of accounts also.